Congratulations, you've learned all the different types of factoring that you are going to do, but now you're going to be given a question and it's just going to say factor, and you're going to figure out what type of factoring you need to do. So kind of like I think when you're identifying like trees and things, they're like, does it have 5 needles? Does it have 3 needles? And you get to kind of pick your path. I've developed this chart to kind of be like that. So every time you approach a question and it says factor, the first thing you're going to do is greatest common factor first, 100% of the time. If you don't, it's going to make your life harder. Now, which isn't the worst thing. So if you don't and you make the life harder, just make sure that you greatest common factor in the end. So it's almost like try to greatest common factor all the time. Then once you've greatest common factored, you're going to look to see if it's factorable. And if it is, it'll have either 2 terms, 3 terms, or 4 terms. If there's 2 terms, you're either going to do a difference of squares, or you're going to do a sum or difference of cubes. How do you tell? Well, a difference of squares is going to have even exponents. The coefficients are going to be things like 1, 4, 9, 16, and so on. Some are difference of cubes. The exponent is going to be divisible by 3, and the coefficient is going to be something like 1, 8, 27, 64, and so on. If there's 3 terms, we're just going to say AC method. Now, as always, I like to call it AC method, decomposition, grouping, greatest common factoring, but the overall term is AC method. Now within there, you know that if the A value is a 1, you can go straight to your brackets. If you recognize it's a perfect square trinomial, you can factor it as such, but I've kind of come to a place where I like simple is best, and so I'm going to say if there's 3 terms, just do the AC method. If you know the other things, awesome. If there's 4 terms, you have no choice but to factor by grouping. Okay, all right, here we go. So I'm going to approach these 5 questions where it just says factor, and I'm going to figure out what to do. The first thing I'm going to always try to do is greatest common factor. So looking at this one, I have a 10 and 150. So I see that 10 can go into both of these, and then I have a t and nothing, so just a 10. So I'm going to take the 10 out front, and I'm left with t plus 15. Am I done? Well, some of the signs that you're done is that you have a linear factor, meaning the exponent on the variable is a 1. That's a good sign that you're done. Yeah, that's pretty much the only sign on this one that you're done, and there's no more greatest common factor. Let's move on to the next one. So in this next one, is there a greatest common factor? Nope. So I move along the tree. How many terms are there? 2. The exponents are even, right? I've got a coefficient of 36 and I'm separated by a minus sign. So this one's going to be a difference of squares. To factor a difference of squares, I draw 2 brackets. One gets a plus, one gets a minus. I take the square root of the first term to get 6x and I write it first. I take the square root of the y squared to get y and I write it second. And it's done. Always check to see if you can greatest common factor in the end, because maybe you missed it in the beginning. This next one, I try to greatest common factor first. There isn't one. Then I notice that my exponents are even. My numbers are perfect squares, but it's a plus sign. This is not a difference of squares. So this one we would actually write prime. Prime means that it is only divisible by itself and 1, which means it's fully factored. All right, what about this next one? This one, again, I have 2 terms, so it's either a difference of squares or a difference of cubes. Because my exponents are divisible by 3 and my coefficients are 125 and 27, I'm going to call it a difference of cubes. I draw a small bracket and I draw a big bracket. In my small bracket, the cubed root of 125 is 5. The cubed root of x cubed is x. In the first bracket, the cubed root of 27 is 3. The cubed root of y cubed is y. In the second bracket, I send that text message, SMS, square. So 5x all squared is 25x squared. Then I multiply, so 5 times 3 is 15, x times y is xy. And then I square, 3 squared is 9, y times y is y squared. Then I clean it all with soap. I match my first sign, so the first sign is the same, the second sign is always opposite, and the last one is always positive. And that's done. In this third one, again, I try to greatest common factor first. There's nothing that goes into 1, 8, and 16, and an m squared m and nothing. So I know that I now have 3 terms, so I'm going to use the AC method. Now, if you're someone who recognizes I don't have to do the whole AC method, go straight to your brackets. How do I recognize it? Well, because m squared, the only way of getting m squared is m times m, right? So that I'm looking for 2 numbers that multiply to give me 16 and add to give me 8. If you're not quite there yet, don't worry, I'll do the whole AC method. So the whole AC method goes like this. 1 times 16 is 16. I'm looking for 2 numbers that multiply to give me 16 and add to give me 8. 1 and 16, nope. 2 and 8, nope. 3 doesn't go in. 4 and 4, oh, there we go. I've got 8. And if this had been a negative 8, I just would have done matching signs in here. So I'm going to break that middle term up into m squared plus 4m plus 4m plus 16. Then I'm going to factor by grouping. First group, I can take out an m. I'm left with m times m plus 4. Out of the second group, I can take a 4. I'm left with 4 times m plus 4. And then I've got that common bracket of m plus 4. I'm left with an m plus 4, so I can write this as m plus 4 all squared, which means that maybe some of you recognized right from the beginning that half the middle term squared gives me AC, which means I could have gone straight to here. Square root of m squared is m, square root of 16 is 4, and then brackets all squared. Whew, lots of knowledge there, okay? But worst case scenario, AC method. It does all the work. Now, I asked this question earlier, but how do you know when to stop factoring? Well, you're going to stop factoring when everything is prime. A hint that something is prime, the highest exponent is a 1, right? That's a good indication that you're done factoring. Another one could just be like maybe you have 2 terms, but it's a sum of squares. That's a good sign that you're done. Yeah, and we can add to this list as we go along. But really, we know when to stop factoring when all of our factors are prime. So let's look at this first example. When you look at this first example, hopefully you see that you can greatest common factor first. Out of all 3 terms, I can take what? Factors of 16 are 1, 2 goes into them all. That's going to be it. So I'm going to take out a 2. So I'm going to greatest common factor out of 2 to be left with 8t squared minus 13t plus 5. Whew. What am I left with? Well, I'm left with a trinomial. So we have to see if we can factor it. We might not be able to, but we have to try. So we're multiplying to get positive 40 and we're adding to get negative 13. So negative 1 and negative 40, right? Same signs because I'm multiplying to get positive 40, negative because the middle term is negative. Negative 2 and negative 20, nope. Negative 3 doesn't go in. Negative 4 and negative 10, nope. Negative 5 and negative 8. Ah, there's my 1. So I'm going to keep that 2 out front. I'm going to decompose my middle term into minus 5t minus 8t plus 5. And again, it doesn't matter which order you write these in. Then I'm going to factor by grouping. Out of this first group, I can take out a t. So I'm going to put my t out front. I'm left with 8t minus 5. Out of the second group, I can't take anything, but I'm going to take the sign of the first term always. So I'm going to take out a minus 1. I'm left with 8t minus 5. Because I took out that negative 1, my bracket matches. So now I can take out that common bracket. So I'm going to put the 2 out front times 8t minus 5 times t minus 1. On a test, this question would be worth 2 marks because there was 2 factorings that I had to do. So it's a really big hint when you're writing your test to kind of look what the mark values are to determine how many steps you need to do. This one, again, I look to see if I can greatest common factor first. I can't because this one has a p cubed, p squared, no p, right? No q's, no number. So I'm going to factor by grouping because there's 4 terms. Out of this first group, I can take out a p. I'm going to write it out front. I'm left with p squared minus 4q squared. Out of the second group, I can take a q out of here and a q out of here, so I'm going to put plus q. I'm left with p squared minus 4q squared. Again, I know I did grouping correctly because I've got this common binomial factor. So I'm going to take that factor out front. So p squared minus 4q squared. I'm left with p plus q. 1 mark. This question's worth 2 marks. Why? Well, when I look at this bracket, what do you notice? There's two terms separated by a minus sign and they're still squared. So I said one of the things to recognize you're done factoring is that the exponents are 1. This one we got to the place where the exponents are 1. Here we got to one of my factors as exponents of 1, but this one still had squares, and that's my hint that I'm probably going to have to keep factoring. So I'm going to recognize that this is a difference of squares. So I'm going to draw my two brackets. I'm going to put my p plus q on the end. And then the square root of p squared is p. The square root of 4q squared is 2q. One gets a plus, one gets a minus. And I don't know if I've mentioned this yet, but of course it doesn't matter what order you write these in. If it's p plus 2q plus times p plus q times p minus 2q, or the p plus q's out front, because of the commutative property of multiplication, it doesn't matter the order with which you write these. All right, last one. Okay, this one I think is worth 3 marks if I can remember correctly. It might even be 4. I can't quite remember it, but let's see where we go. So you can pause the video and give this one a go if you want. So I'm going to see this as a difference of squares. It's not a difference of cubes because 16 isn't divisible by 3. So I'm going to factor this as a difference of squares. So I'm going to draw two brackets. One gets a plus, one gets a minus. And you'll notice I change my order of my steps for difference of squares all the time. It doesn't matter what order you do the things in. Square root of 1 is 1. Square root of x to the 16. Now, when you take the square root, you're looking for something that multiplies by itself to give you x to the 16. So you always just take half the exponent. Okay, so x to the 8 times x to the 8. When multiplying powers of the same base, you add the exponents. That gives you x to the 16. Now, am I done? Well, this one's two terms with an even exponent, but it's separated by a plus sign, so this one's prime. But this one is still a difference of squares. Keep going. 1 plus x to the 8. Factor this guy as a difference of squares. I've got 1 minus 1 plus. Again, half the exponent is x to the 4. And what happens? Oh, this guy can go further. So I still have a difference of squares, but I've got another plus. So I'm going to go 1 plus x to the 8. I'm going to go 1 plus x to the 4, and then I'm going to factor this one as a difference of squares. Again, I'm going to draw my two brackets. Square root of the 1 is 1. Square root of x to the 4 is x squared. One gets a plus, one gets a minus. I remembered the order this time. And then again, I have a difference of squares. So I keep going, prime, 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 keeps going. I've got 1 plus x to the 8 times 1 plus x to the 4. That doesn't look like a 4. Times 1 plus x squared, and lastly, two brackets, square root of 1 is 1, square root of x squared is x, one gets a plus, one gets a minus. I'm done because this last one has exponents of 1, so these are linear, and all of these guys are prime. So this would have been worth 1, 2, 3. This would have been a 4-mark question, believe it or not. So always look at the point values because it'll tell you, it's a hint to how many times you'll need to factor. All right, good luck with 5.4.